Welcome back to my channel, and here I have this question which has to do with a why question, and I've solved this particular question before based on what we're asked to do. We're asked to draw the complete plan, and we're also asked to draw the auxiliary plan of this truncated cylinder. But I just look at it that why may decide to bring out this same question but change the questions that we are to ask, make use of this same truncated cylinder. Okay, so I'm going to tell us what I want to do with this question now, as I thought that WAEC may change the question in this particular form. So they may ask us to draw the complete plan, which is what we also did for the other one. We asked to draw the complete plan on also the auxiliary plan. Okay, and then they may ask us to draw the true shape of the cut surface and also the surface development of the remaining part of this cylinder. Three questions: complete plan, true shape of the cut surface, and also the surface development of this truncated cylinder. So those are the three questions that I want to answer here. So we have this truncated cylinder. So the height of the cylinder is 60 millimeters and the diameter is 60 millimeters, and also the distance from this point to this point where the cutting plane touch this side of the cylinder is 15 millimeters, and the angle at which the cutting plane inclined to the horizontal is 45 millimeters. So let's start and see what we want to do here. So what you need to do is to replicate this diagram first, so which I've done, as you can see it here. So the first thing that I'm going to do is to divide this circle into a number of equal parts, that is into 12 equal parts. So I will divide this circle into 12 equal parts. Okay, so I'm making use of my set square to do that. Alright, so the circle has been divided into 12 equal parts. So, and then I'm going to numbers this as 1. So this is 2. So this is 3. This is 4, 5, 6, 7, 8. This is 9. This is 10. This is 11. And here we have what? We have 12. So the next thing that we are going to do is to draw this point into the cylinder as we have here. So we have drawn a vertical line from point 1 to this point on the cylinder. So here now we draw what? We draw point 1, 2 and 3, sorry, 2 and 12 into the cylinder, and also point 3 and 11 into the cylinder. Then we have point 4 and 10 has been drawn, and then point 5 and 9 will be drawn into the cylinder, and also point 6 and 8 will be drawn into the cylinder. So as you can see here. Alright, so having done this, the next thing that we are going to do is to draw the complete plan. So for the complete plan, the cutting plane touch the cylinder at this point. It touches at this point. So what we need to do is to draw a vertical line down here. So the complete plan is very, very simple. So I need to make this line a thick line. So this line will be a thick line from here to here. Okay, so the rest of this will be arched with a 45 degree set square. So what I need to do now is to arch this surface like this, because it's a rough surface, so it is cut off. So don't forget that our arching lines are drawn within continuous line, and they are parallel to each other and also equally spaced. Alright, so we have to take it easy. So I'll pause the video and do the rest, and I'll come back after that. Alright, so this is the complete plan. So we have completed that. The next thing that we are going to do is to draw the true shape. Okay, so to draw the true shape, so since this line or this cutting plane is inclined at an angle 45 degree, so we have to draw perpendicular line to each of these points, so in this direction. So what we need to do is to make use of our 45 degree set square. So we set it at this point like this, and we draw a line in this direction. So mind you, I'm not saying that this is the question that WAEC is going to give you. So I'm just saying that they may bring out this type of question and ask you to do it as I'm doing it here, that you should draw the complete plan, the true shape of the cut surface, and also the surface development. I'm thinking of adding one more question to this, but let's see when I'm done with this. So you also draw this in this direction, and this also goes in this direction. Then so we draw from this point, so it goes in this direction. Then we also draw this point in this direction. All right, so having done this, next thing that we are going to do is to move away a little bit and draw a perpendicular line to this line. So just draw a line like this. Okay, so looking at what we have here now, so looking at what we have here now, if I follow this line, this is line 1. Okay, so based on the numbering that we did in the plan, so then if I go on this line, this point here will be point 1. Okay, so this is point 1, and then this point, so if I go on this line, this point here will be point 7. So we have to get other points. So we need to get other points. So this is point 7. So other point, point 2, point 3, point 4, point 5, point 6, point 7, and so on to 12. So we need to get those points. So we are going to make use of our compass to that. And to do that, so what we need to do to get point 2 and 12, I'm starting with 2 and 12. All I need to do is to put the pinpoint of my compass on this center line, so which is in between 2 and 12. So just take this distance between 2 and 12, or between that center line and 12. So we take it like this. Okay, then we bring it, this line contains 2 and 12, so I put at the center here, and I will make an arc here, then I make an arc here. Okay, all right, sorry. So what we need to do, all right, so I need to draw a vertical line here. What I took now, the distance that I took now is not correct. So this line that I drew, which is in between 2 and 12, so I will take this distance from here to here. Okay, so between this center line and 12, or I can take it between the center line and 2. So I put at this point here on the line that contains 2 and 12. I make an arc here, and also I make an arc here. So this point here, this point is point 2, and this point here is point 12. Sorry, so it's point 12. So then I will put it here to take the distance between this center line and 11 and 3, so which is to get point 11, point 3 and 11. So this point and this point here, so this is point 3 and this is point 11. Okay, so we are moving on. So next is to put it here in between this line is between point 4 and 10. So I just take it from that middle line to 10. So I put at the center here. Okay, and I make an arc here. So this line contains 4 and 10. So I make an arc here and here. So this is point 4, while this point is point 10. Okay, so next is, so I need to draw a vertical line from 5 to 9. We need that vertical line so that we can get the midpoint of 5 and 9. Okay, so I will also do that of 6 and 8. Okay, so I will take distance from the midpoint to 9, or from the midpoint to 5. Okay, so I follow this line that contains 5 and 9, then I make an arc here, and then I will make an arc here. So don't forget that what we are doing is to get the true shape of the cut surface. So I'll take the distance, so from the midpoint of 6 and 8, or 6 and Okay, so I'll come to this line. It contains 6 and 8. Make an arc here, and I make an arc here. All right, so now all these points. So this point contains. So this is 5. This is 5, and this is 0.9. So while this is 0.6, and this is 0.8. Okay, so with my French curve, I'm going to join this together. I will join it, and then I'll come back and show you the next thing that we are to do, or what we get, before we move to the next thing to do. All right, so this is the shape that we got. So now we need to arch this surface, but we are not going to arch the whole of the surface completely. If you look at the plan too, or the complete plan, you see that this part is not arched, because the cutting plane does not touch the distance from here to here. So that's why we left this place unarched. So the same thing must be done to the true shape. So from here to here, so we are not going to arch, so but we are going to draw a thick line here as we have it in the plan. Then we are going to arch the rest of the surface. So I'm not going to make use of my 45-degree set square, so I'm going to use the 60-degree side of this set square to arch this surface. Okay, so I'm going to pause the video and arch it, then I will come back to show you the result when I'm done. Alright, so this is how the tree shape will look. So what I'm going to do now, as I said, that I'm going to add one more question to this. I'm going to draw the end elevation of this object. Let's draw the end elevation and see what the end result will be. So what we need to do to draw the end elevation is to draw a line from this point. So we are looking at it in this direction. So we want to see what we are going to see here. So what I need to do is to draw a horizontal line from here, and then I will draw this line, a center line. Okay, then here I will also draw a horizontal line from this point. Then here also I will draw a horizontal line like this. Okay, so the next thing that I'm going to do is to take my 45-degree set square, so put it at this point. Then I will draw an inclined line in this direction. Okay, then the next thing I'm going to do is to first of all draw the center line. So draw the center line like this. Okay, then from this point I will draw a vertical line, and also from this point I will draw a vertical line. Alright, so having drawn this vertical line, so the next thing that I'm going to do is that from this point I will draw horizontal line from this point 3. So from this point, so we have 3 and we also have 5. So then from this point that contains 2 and 6, I will draw horizontal line. I have drawn that of 1 and 7. Then from here it contains 8 and 12. So I will also draw horizontal line to meet this inclined line. And also from this point that contains 9 and 11, I will draw horizontal line. Then the next thing I'm going to do is to draw vertical line from each of these points. Okay, so here I will draw a vertical line. So from this point also I will draw a vertical line. So from this point I will draw a vertical line, and from this point I will draw a vertical line. Alright, so then having done this, so then I need to number this. So this line contains, this is 4, so this line is 4, and then this contains 3 and 5. So here we have 3, and here we have what we have 5. So 3 and 5, that is this point, it contains 3 and 5. And then this point contains 2 and 6, so this is 2, 6. And then this contains 1 and 7, that is at the center, 1 and 7 here. Here we have 8 and 12, so this is 8, 12. So this point contains 9 and 11, so this is 9, 11, and this is 10. So here we have 10, so this point. Okay, so the next thing that we are going to do now, so to get the end elevation of this truncated cylinder looking in this direction, so what we need to do now is to draw a horizontal line. So this line contains 7, this is 7. So what we need to do is to draw a horizontal line from this point, and then we draw it to the center, because we have 7 at the center here. So this is 0.7 here at the center. So then this contains 8, 6 and 8. So I will draw horizontal line from here, then I need to locate 6 and 8. So here we have 6, on this line we have 6, so this is 0.6, and on this line we have what? We have 8, this is 0.8. Then move up, so this contains 5 and 9. I will draw horizontal line. So where do we have 5? So we have 5 on this line, and then we have 9 on this line. So the next is, so I will draw horizontal line from this point. This line point contains 4 and 10. So draw horizontal line from here. So where is 4? So we have 4 at this point. And then, so here we have what? We have 10 at this point here. So if you follow the numbering, so here we have 10. So the next is, so here we just have a straight line. So this should just be a straight line. So I can just decide, okay, so let me draw it as horizontal line. So this is just a straight line. As you can see here, we are going to see it as a straight line. So that means I'm going to make this line a thick line. I'm going to make this line a thick line. So from here to here, so this will be a thick line like this. Okay, so now, so this point also, so we take note of this point, we take note of this point. So we are going to join this together with the use of French curve. So I will do that, and then I will come back and show you the next thing that we are going to do while I pause the video. Alright, so this is how the shape will look. We are connecting it to this point. So as we have it here, so the cutting plane touches this point, so we are connecting to this point. And then, so we are going to make this line, we are going to make it a thick line. So from here down, and then this will also be a thick line. So from here down, okay, then, so the base, so we also make it a thick line like this. So then the next that we are going to do is to hatch this surface. So I'm going to pause the video and hatch the surface, and I will come back after that. Alright, so this is how the end elevation will look. It's as simple as I've done it here. So as I said, that there is one more question that I want to answer in addition to what we have here, and that is the surface development of this truncated part. So how are we going to do that? I think I can make use of this space. So so let's see how we are going to do that. So so what I want to do now is to okay, so let me make use of this space. I will just manage this space that we have here. I manage this space. So what we need to do now is to draw a vertical line from here. I will still make use of this space. I'll just manage it. So okay, then I'm going to, I already have horizontal line. I'll make use of this horizontal line like this. Okay, so we are going to calculate the circumference of the circular base of this cylinder. So that is 3.14 times 60.